Hello everybody, and welcome back to this presentation from Dr. Mickaël Pruvost from Arkema, who's going to give us a presentation on printed piezoelectric materials. As always, please leave any questions you may have in the sidebar, and we will take these live after the talk. I'm now going to hand over to Mickaël, and I'll see you at the end of the presentation.
Thank you, Chris, for the introduction. So, good afternoon, everybody. My name is Mickaël Pruvost. I'm a researcher and business developer at Arkema. And today it's my pleasure to present to you our Piezoelectric product range, which are electroactive polymer for organic electronics. So first, I'd like to introduce in brief our company, Arkema. So we are one of the leading chemical companies in the world. We have more than 20,000 talents all over the world. We are present in 55 countries with more than 15 research centers in Asia, America, and Europe, which employ 1,600 researchers. So at Arkema, our portfolio of products is based on innovative material for a sustainable world, which balance between adhesive solution, coating solution, and advanced material. And at Arkema, we have decided to organize our research into 5 innovation and research platforms, which respect the sustainable development goals, which are new energy, natural resource management, home efficiency and insulation, lightweight material, and solution for consumer electronics. And the Piezoelectric product line is in this last category. So at Arkema, we produce fluorinated electroactive polymer. It means basically that you can do amazing things with this polymer. For example, you can convert mechanical or thermal energy into electricity, and vice versa. If you give electrical energy to this polymer, you can get a force feedback, a vibration, or a deformation. So initially at Arkema, we synthesize this polymer into the form of powder, but they can be put in the form of film also, or in the form of inks, specially formulated to the flexible or organic electrical market. So following our mission at Arkema to create unique material with unique properties, we have developed 2 product lines. The first one is the copolymer Piezotech FC, which is a PVDF TRFE. Here you can see the molecule. It's a fluorine-based molecule, and thanks to this fluorine atom, you get the electroactive property of this polymer. So what are these electroactive properties? First, with this product line, you have a piezoelectric effect. So a direct one, from a deformation you can get an electrical signal, and a reverse effect, from an electrical signal you can get a deformation. Here, for example, on the first video, you can see a use of the direct piezoelectric effect. This is a sensor. You can see a piezoelectric sheet. Somebody is bending the piezoelectric element, and thanks to an electronic card, you can easily follow the deformation. From the reverse effect, you can do basically actuators. Here you see an example of microbeams moving. The deformation is proportional to the voltage that you apply. And also, this polymer have a pyroelectric effect. It means that from a temperature variation or a temperature gradient, you can get an electrical signal. This is useful to do temperature sensor or a gradient sensor. Here, for example, an application, you see from the temperature difference between the hand of a human and a piezoelectric sheet, you can follow easily the position of the hand just by the temperature difference between the hand and the substrate. Also, at Arkema, we have a second range of electroactive polymer, which are the terpolymer. So they have different property compared to the copolymer. For example, they have a large electrorestriction. It means that from an electrical signal, you can get a deformation, but compared to the reverse piezoelectric effect, this deformation is much larger. It means that you can go to other applications, for example, actuator for haptic devices. If you put this material inside glove, you can get real force feedback with a large intensity. Also, this material have a very large ID electric constant. It means that you can generate very numerous electrical charges, and this is useful, for example, to develop basic electronic components such as flexible transistor or flexible capacitors. So at first, at Arkema, we start with the powder, and the first step to print our electroactive material is to do an ink. So we have a mixture of the electroactive powder plus a